Hi, welcome to the section of coding for driving the Nokia display. The very first thing I would do is importing the library, which is very much important to drive the PCD8544 display, which is available over GitHub at this provided link. You can directly download, or you can directly take the file that I give you for download in Udemy. What I do is importing the SPI library, which is essential for to communicate with PCD8544. The next thing is the table which has been pasted here tries to strictly stick to the pin description which is provided in your previous lecture and also the connection diagram. First of all, I'll create an SPI object and I decide the baud rate or the data rate, which is 20 MHz. As I said, SPIs can go up to higher speeds. And here, as I discussed previously, I'm trying to set few settings called polarity and phase. In our case, the polarity and phase are 0, 0. And now we create few objects in order to work with the 8544 library, which are the SPI communication itself and few enable data command and reset pins. So we create few pin objects for enable, data high and reset pin. The pin description or the pins which it is to be connected, it is as before, which has been explained in the previous lecture, and you can strictly follow this table. So then I pass the SPI object and the pin objects into the PCDFP 8544 library routine. If you see inside the code also, it is available, whatever it takes. It has a set of functions in order to enable or drive the PCD8544 display module. It involves in initialization and also resetting the device and providing few commands and setting few contrast settings, etc. We will not go much deep into this code. Coming to once the LCD object has been created, I just want to draw few pixels or enable few pixels. The function I use is lcd.fill. lcd.fill in brackets 0 will fill zeros in all the pixels of the display. In a sense, we are trying to clear the display. And I'm trying to enable a pixel. This is the enable bit. And these first two are the coordinates of x and y of the display. In our case, it is a 84 by 48 display. So a midpoint of 84 in horizontal will be 42. A midpoint of vertical 48 will be 24. So in the next code, next line, I'm trying to enable a pixel, which is the midpoint, diagonal midpoint of the display. And I'm also trying to let a corner of the display. And then I use the command lcd.show. In other words, lcd.pixel is trying to create a buffer and lcd.show is trying to push the buffer at a time onto the display. So all these changes are going to reflect only when you call the routine lcd.show. In the same way, you can draw few waveforms also. Here I am trying to draw a sinusoidal waveform where the first coordinate, the first parameter is the height or the amplitude. The second is the repetition rate or the frequency of the waveform, and the next is the phase. So how the sinusoidal function drawing would work? Simply, what I was trying to do is, I was trying to use the mathematical library which is available with NodeMCU. So I have imported math. I'm just trying to draw a sinusoidal waveform, the phase being 0, and I here is the frequency. The frequency is the second parameter what we passed. What I have passed is 360. So that is the repetition rate. Here, what I'm trying to do is, I'm trying to convert the degrees into radians, for which we have to keep a note that 1 degree is equal to this many radians. So that is why the math routine which is there, the sinusoidal function routine which is there in the math library, tries to accept parameters in radians. So I have converted the degrees into radians. So the phase is 0, I is the frequency point 0 or the 1 first, which has been passed as a parameter of the sinusoidal function, and height of it is been decided by amplitude. And now y is the offset. Y is, in fact, we are trying to give the offset in the mid of the display. So that is why I put 24. So this makes you the respective coordinate, the y coordinate, and x coordinate is nothing but the total horizontal display 84 is been divided with frequency. So that many points will be created, and for that particular x point we are trying to highlight the y point. So those become the coordinates and we are trying to enable them. Once this complete buffer is filled, I'll try to use LCD.show, which draws the waveform of sinusoid. In the same way, I would draw also the cos functions, where I use a cos function in the math library. Similarly, you can play with the frequency repetition rate of the sinusoid, also changing the amplitudes, also changing the phases. If you want to fill any text or draw any text, we'll just use the routine lcd.text. lcd.text with the coordinates where you want to print it. This is the mathematical waveform output, where I was saying the offset being 24 is this. That means the offset is exactly in the middle. This is a different negative phase. I mean, there is a phase shift here. This is not 0. Considering this as x coordinate and this as y coordinate, we are trying to enable few pixels and trying to draw the sinusoidal waveform. In the same way, if you see the text, and when you compare it with our code, I'm trying to write some text starting at 0, 0, 1. Here are few spaces. That is why there are some spaces here. And I'm trying to print in different coordinates. So you have to remember that each character height is 8. So the character height here is 8 pixels. So that is why I have taken in the multiples of 8. 0, 0, 8, 16, 24, 32, 40. So in a sense, I am trying to print in each lines. My coordinate x being always 0. That means I am starting at the starting of the display, and the characters continue in the same line. So only I am changing the y coordinates. The x will be starting at 0 only. Hope this explains, and you try to experiment this by your own, and you can try to play with the waveforms and also your own text and also whatever you want to show as graphics, etc. Thank you.